Hi, welcome to this virtual field trip of the red rocks of the Sedona area. Sedona is about 2 hours north of Phoenix. It's in central Arizona. It's a little less than an hour south of Flagstaff. And Sedona is very famous with tourists and with geologists because it has these spectacular exposures of red rocks, which actually are not that well understood. The feature behind us is called the Mogollon Rim, M-O-G-O-L-L-O-N Rim. And it's the topographic feature that's formed essentially an escarpment held up by Permian rocks. And all the rocks behind us that you can see in this view are all Permian in age. There are other Paleozoic rocks below us, down to the Devonian, and there are basalts and things like that on top of the Paleozoic rocks. But the red cliffs themselves are mostly Permian. Traditionally, these rocks were always called the Supai Formation, correlated with the Supai, the red rocks in the middle of the Grand Canyon. The precise correlation between those units, though, has not always been very well known. The upper part is a cliffy sandstone, and then you can see just the start of some more ledgy rocks down below. The rocks I'm standing in has a lot of slope-forming siltstones and things like that. And so traditionally they've used three letters, Supai A, Supai B, and another unit which you can't see from here called Supai C. The light-colored rocks on top is the Coconino sandstone, and it is equivalent to the big cliffy unit that sits above the Hermit in the Grand Canyon. It has the same character here as in the Grand Canyon. It's a quartz sandstone with large-scale crossbeds that are interpreted to be Aeolian in origin. So this is thought to be just essentially a continuation of the big sand sheet that deposited the Coconino in the Grand Canyon. An interesting rock in the sequence, about 2/3 of the way up the cliff, is there's a little thin layer of gray limestone called the Fort Apache limestone. It's a marine limestone. It's Permian in age. It's actually been recently redated as Leonard in age with fossils. And so we know the age of those rocks. And so, that's a marker. That unit thickens off to the southeast and eventually becomes part of all the Permian and Pennsylvania units that are down in southeastern Arizona in a big basin called the Pedregosa Basin. So that unit comes in here and thins and thins and thins, and not very far that way, it's gone. And so although that's a nice unit to correlate from here to the southeast, it doesn't help us between here and the Grand Canyon, because this unit is not present in the Grand Canyon. So one of the issues is that the units are thickening to the southeast towards the Pedregosa Basin, and then in the Grand Canyon, the units are thickening to the west towards Nevada. And between those two is a little area called the Sedona Arch, which we're in. And it evidently was an area that's just subsided a little less, or maybe it was a positive area at times. And so the units from southeast Arizona lap out against it, and the units from the Grand Canyon come in, and there's a facies change in here. So it's really hard to try to correlate the units in the Grand Canyon with the rocks in here. As we go along today, we'll talk about what some of those issues are and some of the ways we've approached it. We've done a lot of detrital zircon work on these sandstones in here to try to better constrain what the correlations are with the Sedona rocks and the Grand Canyon. It's a little amazing. It's this very famous place with geologists, and we don't quite understand it.